Okay, we're going to do section A3, which is polynomials and factoring. A polynomial is an expression in this crazy form where we just make the a be the coefficient and we have the subscript match the exponent. The crazy thing about it is that the exponents are non-negative integers. We learn non-negative means 0 or positive. Most people do not put the x to the 0 on here and wonder why it's a to the 0, but you need to realize, what does x to the 0 mean but 1? So I like to put it on there. The coefficients can be any real numbers. What is not a polynomial? Any variable expression with positive exponents in the denominator. It's not and that means when simplified, folks, when simplified, it's not going to be a polynomial. Variables whose exponents are negative in the numerator, or a radical, or a fraction, or transcendental like trig and pi and e. The constant coefficients can always be radicals and fractionals and transcendentals. The degree of polynomial is the value of the largest exponent. The degree of each term is the value of its exponent. The leading coefficient is the coefficient of highest degree, which is the largest exponent term. Standard form is when you write the polynomial in terms placed in descending order of degree, that is largest exponent to smallest exponent, left to right. Now I'm going to ask you to state whether something is a polynomial or not, and if not, why, and if it is, put it in standard form. This first one is not. It's simplified, and notice I have a variable with a positive exponent in the denominator. It can't be. The next one, notice all exponents are integers, technically x to the 0. None of them are negative, so I put it in descending order from left to right. So the 5th power, the 4th power, the 2nd power, the 1st power, and the 0 power. Problem 3 is not. This is not a non-negative integer. It's indeed positive, but that's not an integer. The next one, this is not a non-negative integer. It's a negative integer. So indeed, it is not going to be a polynomial. The next one, all exponents are positive, but 3/2 is not an integer, and it's on the variable, so it's not a non-negative integer, so it's not a polynomial. This next one looks weird, but it's okay because the fraction is a coefficient, the decimal is a coefficient, and remember, this is the coefficient of x to the 0. And so, indeed, 1/2 x cubed plus 0.5 x squared minus 2x minus root 2 is indeed a polynomial. Now we're going to add and subtract. I've put in red something that is special. When you come down here, folks, a lot of people will just write a +2, or they'll write a +6, or they'll write a -3. I don't know what it is about this very last term, not here, just at the end of all your multiplying that people screw it up. I've put it in red to make sure you're not gobbles. And so you just go ahead and multiply and combine. For the next one, I didn't put it in red. I just went ahead and distributed. And so we're doing fine. I just multiply -2 times the first, 3 times the next. I organize it and put it in descending order. Now, we're going to factor, but before we do factoring, we need to do some basics. Remember some basics of sign numbers. 1, when you have like signs, you're supposed to add, and the sign remains the same. So positive plus positive is positive, negative plus negative is negative. When you multiply, an even number of negatives gives you a positive. Unlike signs, you subtract. The number further from 0 is the winner. So 3 wins and 8 wins. So I get a -1 and a +6. When I multiply unlike signs, since there's an odd number of negatives, my product is negative. Now this is going to be useful as I review multiplying binomials where the leading coefficient of the linear factor is 1. Yeah, get my tongue right. So I'm going to take x times the x plus 3 and 2 times the x plus 3. I do the work. I have to do x times the x minus 6, negative 5 times the x minus 6. Yes, do the work. I do x times x minus 3, 2 times x minus 3, do the work. I'm using my distributive law. I do x times the x plus 8, negative 2 times the x plus 8, yes, using my distributive law. Now, hopefully, you all aren't when the leading coefficients are 1 and the factors are linear. At this point in your math career, you should be cognizant and familiar with the pattern. All these leading coefficients are 1, so I get x squared, add them up, 5x, multiply them, 6. X squared, add them up, negative 11x, multiply them, 30. X squared, add them up, negative 1x, multiply them, negative 6. X squared, add them up, which is subtraction, 6x, and negative 16. If you're not familiar with that pattern, there is a reason why you all have trouble with factoring, and for some of you never really got it down. Knowing this pattern will easily let us factor polynomials where the leading coefficient is 1 and there is no common monomial factor. So I come over here, I notice product, sum, product, sum, product, sum. So I look at the product. Oh, it's positive. That means I have like signs on my factors. Well, what are the only factors that could give me 15? 1 and 15, 3 and 5. And I know they're both positive or both negative. I don't care about that right now. And so what do I do when I have like signs? I know I add. So if I ask you like signs and I tell you to add them, I actually do addition. Oh, but the answer is negative, so my like sign was negative. And what gave me 8 was 3 and 5, so I make sure they're both negative. X squared minus 13x minus 30. Product, sum, product, sum, product, sum. So I come over here, I see the negative 30. Ooh, that means unlike signs on the factors. I listed all my factors. Now, what do I know? The middle term comes from a sum. How do I sum unlike factors? I subtract. Careful, 3 and 10 add and give me 13, but this tells me they're not the same. They're unlike, so I have to use 2 and 15. I like to think of the game as winner and loser. When you have unlike signs, the larger number, that is the one further from 0, is always the winner. In this case, what's he going to win? Negative sign for the 15. 2 is the loser. What's the booby prize? Well, negative's been used, so positive is what is left. Next problem. Product, sum, product, sum, product, sum. So I go ahead, list the factors of 24. I see it's a plus, so that means there's like signs. I have to be careful because if I subtract 12 and 2 give me 10. When I add 4 and 6, what do like signs tell me I'm doing? Adding. And so I know I need a positive 4 and a positive 6. Last one. Product, sum, product, sum, product, sum. I come over, oh no, unlike signs, notice 6 minus 1 gives me 5, and 2 plus 3 gives me 5. I'm supposed to be doing unlike signs, so it means subtracting, so I want 6 and 1. 6 wins the sign. What does he win? A plus. So what is the booby prize for 1? The minus. Now that we know what happens when the leading coefficient is 1, what happens when the leading coefficient of a quadratic is not 1, but a perfect square on the first term, and the last term is also going to be a perfect square. Moving to the next room, we will look at these. And when we come over here, I don't use A and B. I use F for first term, L for last term. A difference of squares says that your two terms are squares, but it's a difference. So notice that's not going to have a plus sign because the word difference says it's going to have a minus sign. You were taught that you take the square roots and add them and subtract them. But I need you to understand vocabulary. What are the factors of a difference of squares called? They're called conjugates of the square roots. So how do you factor a difference of squares? It's the product of the conjugates of the square roots. What is a conjugate? Well, the conjugate of 2 plus 3 is 2 minus 3. The conjugate of x minus y is x plus y. The conjugate of whatchamacallit minus Hussentuffer is whatchamacallit plus Hussentuffer. That's all that a conjugate means. I really want to show you that x squared minus 4 could be done as a trinomial. Put in the 0. Notice this is negative, so unlike, I list the factors. I want to subtract and get 0. It's just 2 and 2. I know the signs are unlike. There's not a winner and a loser. One's plus, one's minus. Now, I don't expect you to do that. I simply expect you to say, oh, I see a difference. Everybody's a square. What are my cute square roots? They're listed. What am I going to do with them? I'm going to write a product. I'm going to list the numbers twice, once with a plus sign, once with a minus sign. Perfect square trinomial, which I refer to as a PST, says that both ends do have positive signs and are squares. In the middle, it's going to be the first times last times 2 with a plus or a minus. If it's a plus, you get a plus. If it's a minus, you get a minus. Now, I see this, rather than moving into trying how to factor it, I say, wow, I notice both ends are perfect squares. Let me take the square roots, 6x and 7y, and then I take the 6 times 7 times 2. I had to fix that. It's still not really legible. It wasn't legible before I had my red pen, but anyway, that was an 84. And so I end up with, yes, it worked. What was the sign in the middle? A minus. So I take the red ones and put them in the middle with the minus sign as a quantity squared. The next one, what are the square roots? 5x and 12. Is 5 times 12 times 2 120? It is. What sign goes in the middle? I originally had a minus there, and I caught myself as I double-checked it, and I made it a plus sign. Now, there are special cases of odd prime powers in your notes. Okay, I'm not going to go over those. The college professors will expect you to know them. I'm only going to review sum and difference of cubes that you learned in Algebra 2, and you will have to know for the SAT. The sum and difference of cubes that I abbreviate SC and DC. Here's the beauty. Sum of cubes, everything's a plus. This middle's a plus. Both binomials are pluses, but the trinomial has a minus in the middle. Minus, binomial minus, trinomial plus in the middle. Because the rule says take the cube roots, including the sign, to form the binomial. Then to get the trinomial, square the first, square the last, first times last, not times 2, but negate. Square the first. When you square a negative L, you get a positive L squared. First times last, negate. So, again, when you take the cube roots, include the sign to form the binomial. For the trinomial, you take the binomial and square the first and last. That means they're positive. And the middle sign, you're going to negate the original sign. So, I took my cube roots, 3a, negative 5. I formed my binomial. Square it. Notice they're nice in purple and they're all positive. And then what do I do with these? I multiply them and negate. So a negative turns into a positive. Next one, I take the cube roots, including its sign. I form my binomial. I squared the first and the last. See, they're nice purple and positive. First times last, negate. So the plus becomes a minus. Now we're moving into grouping. We're going to start with ones where you must group. Now, I know that I could use fancy terms. I want to show you the pattern first. Take the first 2 terms, common factor. Whatever the binomial is, we write it once. On the same line, we write it twice. And on the line underneath, we write it thrice. And then I come and I ask myself, okay, what's the common factor? It's going to go in the same place first. X times what gives me bx is plus b. I formed it. Technically, what am I doing? I'm factoring out the x minus y, and the leftovers are a plus b. But that gets confusing as the problems get messy. Common factor, the 4 is out. What is the binomial? I write x plus y once. On the same line, twice. On the third line, thrice. And then the 4 stays coming in. X needs a negative c, 4 minus c. Notice it's just the common factor. For the last one, it's messier looking. Same idea, common factor, the x. Now what's the binomial? 3a minus b, I write it once, twice, and then underneath thrice. I play the game. 3a needs what to get to negative 12ay? Negative 4y. And so I have x minus 4y. Now, I know a lot of people teach you this stuff by dividing, but you all are much better multipliers and adders than you are dividers. So now here's one that should have been a plus x, but I've already split it up. We're going to do it the same way. Notice I common factored the 2x. Whatever this binomial was, I wrote it once, twice, thrice. And then I said, 5 times 3. So I get a plus 3, so 2x plus 3 go in the second factor. For this one, that should be a negative 32 up there, but I've already played the game, so I'm going to factor. I have 3x minus 2 that I write once, twice, thrice. 3 times negative 10 gives me the negative 30, and so x minus 10 are the missing terms. Now, I'm going to do this for when the quadratic has no common factor, but the leading coefficient is not 1. Two things that are slightly, maybe 3 things that are slightly different. First, I have to take the first times the last, so I get 120. Yes, I'm still going to list all the factors. But I'm not looking for 24, I'm looking for 120, but I need this sign. It tells me they're unlike. So what am I going to be doing with these dudes? I'm going to be subtracting them. And when I subtract them, I want to get 2. So I look at my list and I see 10 and 12 give me 2. Since I'm subtracting, the larger number wins the sign. The smaller number gets the booby of the other side. So now what I want to do, though, is not write them as factors. I want to put them in this form. So I stretch these two numbers apart and ignore the negative 2 and make it a bigger space and put in positive 10x minus 12x in its place. I start the process again. I'm just going to common factor all binomials x plus 2, write it once, twice, thrice. X times what gives me negative 12x, negative 12. And now I factored a messy problem. One more. I give you this. What am I going to do? I'm not going to use the 5 for my list, but I'm going to use 8 times 5. And 8 times 5 is giving me 40. I list all the factors. What is the sign on 5, though? It's 5. It said these are like. When you have like signs, what do you have to do? You need to add. So which ones give me 22? 2 and 20. When I add whatever sign is there, I need to keep. So instead of negative 22, which I'm going to throw out, I'm going to split the red C a little more so I can insert the number negative 2x and negative 20x. In the place of just negative 22x. I'm going to common factor the 2x. 4x minus 1 once, twice, thrice. 4 times what gives me 20? Negative 5. And now I have factored. All right, apps. These are popular apps when they'll just give you a rectangle and a rectangle. And it can be a picture. It can be a swimming pool. It can be a garden. It can just be about anything that they've got going on there. Notice the big rectangle, I say A for all. The stuff in between, I call B for border. I call C the center. How do you get A? You add B and C together. How do you get B? You take A and punch out C. How do you get C? You take A and punch out B. So now I'm going to ask you to find the green shaded area. And like I said, this could be a piece of paper where you want to know how much area is really in the border is going to take out of your typing paper that you're creating. Again, how much area is the sidewalk around a garden or a pool? What is the size of the border around my picture in a frame? So at any rate, what am I going to do? I'm going to say find the shaded areas. So my large rectangle A, I multiply. My small rectangle, I multiply. Notice this is mono times bi. Once I get them, to know the border, what do I know the border is? It's always A minus C. I've got to remember that I have to use parentheses. I wouldn't have to use it here, but it's just good mathematics to show it. Here I need it because of the minus sign. Please be careful. Don't forget to multiply that number, please. Poor guy, he gets so upset. He's so forgotten. So I end up with 9x squared plus x. I give you a similar figure, but this time I'm giving you binomials. And I'm hoping at this point in your career you don't have to write them all out, that you can go 4 times 2 is 8, and negative 1 times 3 is negative 3, and 8 minus 3 is 5 in your head. But if not, go ahead and show it. And here I'm just going to add them, and I'm going to multiply them. And when I do my A minus C, notice, do not forget to distribute. Most of the time you do this one right, this one right. He's the last one. He's the one people mess up. So please, 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 please be careful. Now, lastly, we can be given an area problem and ask for the perimeter. There have to be specific parameters if I want this perimeter. My lengths have to be linear, so I can't just come down here and say, oh, take out the 5, because then that would be confusing when I go along. So each side will assume is linear and can be obtained from the factors. So I factor, and notice 5x has x to the first, so it's linear. X minus 4 has x to the first, so it's linear. I set up my rectangle. You don't have to show the work. You just have to be able to realize that I take these factors and add them and double them, or I write them each twice. And so I end up with 12x minus 8. Now, I'm not going to do practice problems like I did before, because there's plenty after the 24, 25, however many pages of notes there are. You'll go down and you'll see problem set A1, A2, A3, and so on. And I think the problems in A3 are really good. So if you want to practice something on your own, fine with me. Here are the answers. You know, we don't care. You don't want to practice. We just want to make sure you get this in your head. So for those of you that didn't take Algebra 2 last year, just had geometry, you probably want to do a little more practice. For those of you that had Algebra 2 last year, you might want to look at the last couple of problems that deal with these ideas that I've expressed here. It doesn't matter. If you have questions because you've done them, that's fine. You can ask your teachers. We will be more than willing to help you with this work. So, end of section A3.